Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Just Some Clued Digits by Mello Robinson. And here are the rules. The first set of rules is so these rules are basically chaos deconstruction, but um, it's a different kind of chaos deconstruction, I guess. Normally, chaos deconstruction is a set of, you have 3 by 3 boxes, and you try to deconstruct the grid into that. But these are actually locate 8 orthogonally connected regions in the grid, each containing the digits 1 through 8 without repeats. And cells not in a region do not contain a digit, and digits do not repeat in a row or column. So I guess because this is 1 through 8, these are orthogonally connected regions, but not necessarily a 2 by 4 or a 3 by 3 as we normally have in normal Sudoku. These are 8-cell orthogonally connected regions. And what is an orthogonally connected region? It means you can go from any cell in that region to any other cell in that region just by going through edges, all while staying within the region. So this is an example of a valid orthogonally connected region, because to get from this cell to this cell, you can just go through these edges while staying within the region. This is an example of an invalid orthogonally connected region, because these two cells, even though they can get to each other by going through edges while staying within the region, they can't go to the other cells in the region by just going through edges while staying within the region. They either have to go through a corner or exit the region to connect to the other cells by going through edges, and that is not allowed either way. So this is a chaos deconstruction rule set, but with orthogonally connected regions. And you can't have repeats in a row or column. You can't have repeats in the region. And cells not in a region do not contain a digit. In other words, they are an empty cell. And that leads us to the other rule, which is basically Japanese sums, where a number outside the grid gives the sum of a contiguous run of cell or cells, so it could be one cell or it could be multiple cells, that are in the same region in that row or column. Oh, a contiguous run of cells that are in the same region. So keep that in mind. You have to be in the same region if you are part of the same run for Japanese sums. And any such run must be flanked by empty cells or the grid edge. Oh. Huh. Okay. Runs are clued in the same order as they appear. And in a row or column with a clue, all runs are clued. A star may represent any number of valid runs, including none. And runs noted by a star are not necessarily flanked by empty cells. But since, okay, that's, okay, I actually did, I did a version of this before. I tried to basically, but I forgot to actually include what orthogonally connected regions are. But I didn't understand what it meant by that. Where any such where is it? Any runs noted by a star are not necessarily flanked by empty cells. And the reason why is because the runs are basically must be sets of cells that are in the same region. So you could have something, so these runs, if they are specifically highlighted by the Japanese sum part of it, they have to be in the same region. But if they are separate runs which are denoted by the star, what that means is that they could be runs of regions which are not in the same region, but they don't have a break through it. So what this could be is something like you have a region here, you have a different region here. It doesn't have to actually be the different region. They could actually be the same region. But we know that every digit on that run is the same region, guaranteed. And then you could have runs here, which are not actually separated. They are different regions, but they are different runs because they must have digits in the same region for the run. Now, for the Japanese sums that are not designated by the star, they must be flanked by the edge of the grid or an empty cell. But the runs designated by the star do not have to be flanked by empty cells or the grid edge. So that's why this could work, right? And I didn't understand that before, but now that I'm redoing this because I forgot that in the intro to describe what a orthogonally connected region is, now I understand what they're talking about. Because in the Japanese sum rule for this rule set, the sum of contiguous run of cells they have to be in the same region specifically. So this could be a singleton here with another sum adding up to a singleton digit. Again, it cannot be... Okay, so for... I forgot, I didn't get to the A question mark. But basically, a star may represent any number of valid runs, including none. And runs noted by a star are not necessarily flanked by empty cells. So example like this is a run that's not flanked by empty cells, but they are a different region than the other runs around them, right? We could also have nothing here, right? So this could be run here, and then nothing. Because the star could be no runs at all also. And finally, we have a question mark represents any digit 0 through 9, but no clues may have a leading 0. So we know there's a guaranteed sum here because you can't have a leading 0. And so it has to be 1 through 9 is the sum. Same with this run. It has to be 1 through 9 because you can't have a leading 0. We know this is a 2-digit sum because it has 2 question marks and you can't have a leading 0. So this is a 2-digit sum for the third run in the column. And we know, for example, we have 4 runs in column 9. We have 2 or more runs in column 8. And the last runs don't have to be, they can be all connected to each other, but they have to be different regions if they are a different run. It doesn't really matter what it is, though. It could be like all 5 are in the same region. That would be fine, too. So, but those are examples of how Japanese sums work. And let me make sure, but did I cover all the rules? Because I don't want to redo this again. Yeah, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. I did a little bit before, so I have a little bit of knowledge beforehand. But one thing we did learn, or one thing I was thinking about, was anytime you have chaos deconstruction, you need to figure out what are the most restricted... Actually, this is actually most Sudoku puzzles in general. Try to figure out what's the most restrictive thing that you have and go from there. And at first I thought this was going to be the most restrictive, because it actually is kind of restrictive, thinking about it. But actually thinking about what values are possible, it's actually row 6 that is the most restrictive. Row 5 is also very restrictive. And it's probably sort of on par. And I finished both of, or I didn't finish both of those. I basically did both of these in the previous video, and then realized I didn't talk what an orthogonally connected region was. So let's go and figure out what my logic here was. Why is row 6 the most restrictive? Well, we have no repeats in this puzzle, and these are the digits 1 through 8. which adds up to, at most, 36. Well, we know these runs here for these three have to be a two-digit run, sum, 16, and another two-digit sum. Well, the two-digit sums can only be 10 at minimum because there's no leading zero. So 10 plus 10 and 16 adds up to 36, which is all 8 digits must be in this row. And there must be 2 empty spaces because these runs specifically are blocked, are designated. They are not star runs. They are just already given runs that we have. So we know that we have 8 digits in this row and two empty cells. So that means we are guaranteed the edge of the grid have to be non-empty cells because they have to have digits in them. Because we have 10 digits in a row, we have 2 empty cells, and we have 8 normal filled-in cells. So that accounts for all the cells. And since we have to have the empty cells be between these runs, and each two-digit sum is at least 2 digits. So this is 2 digits here, and this is at least 2 digits here. 16 cannot be a 2-digit sum because we don't have 9 available, and you would have 7 and 9 for a 2-digit sum in normal Sudoku, but here we have at most 7 and 8, which adds up to 15. So the middle run must be at least 3 digits, and it could be 4. If it's 4 digits, where are the digits? They have to all be here. If it's 3 digits, where can they be? They could be here and here, or here and here. Either way, these 2 digits are guaranteed to be in a run. They have to have a filled out digit. Now, that's the information that we have for row 6. For row 5, we have a 6, an 8, an 8, a 7, and a blank. Well, we don't have 2 8s in a row, so one of these 8s is going to have to be a run of 2 digits adding up to 8, 2 or more digits adding up to 8. And if we have a 6 here, so we have a single digit, we have to have a blank between all of these runs. So we have a blank between 6 and 8, that's 1, 8 and 8, 2, 8 and 7, 3, and 7 and question mark, 4. So we have 4 blanks in the row already. We have guaranteed 1 digit here, 1 digit here, 2 digits here, or it's 2 and 1, either way. So that's 4 for these first 3 runs, 5 for 7, and 6 for the question mark because it's not 0. So that's 6 filled in cells and 4 empty cells, which account for all the cells in the row. So therefore, this also must have a digit on the ends, but we know exactly where the where there has to be more than 1 digit. It has to be either in the first 8 or the second 8. So the first 6 has to be a singleton and therefore is a 6. The second 8, we have something here. Sorry, the first 8 is here. It's either 8 here, blank, and then 2 digits adding up to 8. Or this is 2 digits adding up to 8, blank here, and then an 8 here. Either way, this is guaranteed to be a digit, and then we have a blank here. And then that's followed by a digit with a blank. So we know this is 7 and this is 6. And these have to add up to 8 if they're 2 digits, or they have to be at 8. So this is 3, 5, or 8 here, 3, 5, or 8 there. And we know these are in the same region. Actually, let's not use blue here. Let's use dark. Okay. And this is where I actually was when I realized that I didn't talk about orthogonal connected regions. So let's continue. I'm not sure where to. Okay. 26. Can you add up to 26? Well, you can't even add, in normal Sudoku, you can't add up to 26 with 3 or fewer digits. It's always going to be 4. And we have a guaranteed 26 and then another guaranteed run after, which must be separated by a blank cell or the edge of the grid, or must be flanked by. So this can't be 4 digits here and then another region here. Therefore, we have to have 4 here, and it must add up to 26, which with 5, 6, 7, 8, that's the max, that adds up to 26. So this must be a 5, 6, 7, 8 quadruplet. This then has to be 1 through 4 here. These are all in the same region. Okay. Here, this has to be a singleton run because you can't have a run here and then followed by blank here because this is obviously filled out. So this must be the first run, and it can only be 5 because it has to be 5 through 8. So that eliminates 5 through 8 in the rest of the column. And we have to have a blank here and then a blank here. What else do we have? We have an 8, a 2 digits 8 blank, 2 digit sum blank, and then single digit possible. So we don't have any information there. This must be add up to a digit sum either this way or this way. We don't know which. And they are in the same region. So that means it can only have 1, 2, 3, 4 in that sum. Oh yeah. Here. Can this be not part of the 19 sum? And the answer is no. Because 19, you have to have 3 digits at least add up to it. And obviously you can't have 3 digits here. This is a blank. So this has to be part of the 3 digits, which means we have to have a 4 either here or here. And it cannot be 1 and 3 because that would then, this run would not have a blank in between, that would flank it. So either this is 4 or this is 4. We're not sure which. This adds up to 19. So it's either, it could be up to this 4. Or it could be this way. We don't know. We have 7 here. We have blank, blank, 13, 3, and 1. So the same in column 5. So it's similar to how it works for row 5, except the 13 is guaranteed to be 2 digits here. So, okay, we know this is an area, this is a boundary, this is a boundary. We got boundary here, here, here. Boundary here. So we know we have something here. We know we have something here. And it has to be singleton digits. Because again, for each of the runs, you're guaranteed at least 1. For the 13, you're guaranteed at least 2. So that's 6 designated filled in cells. And between the runs have to be surrounded by either a blank, empty cell, or the edge of the grid. Well, that gives us 1, 2, 3, 4 blanks, which accounts for all the cells in column 5. So we have singleton, blank, blank, singleton, blank. It has to be both of these then. Both of these have to be in the same region. And then that adds up to 13. Then we have blank, singleton, blank, singleton for column 5. And this has to be a 1, and this is a 3. Then has to be a 3-5 pair. This is blank here, so this is 8. This can't be 3 or 8, it's 5. 5 and 8 add up to 13, so this is 8 here. And that makes this a 3. This is all the same region. So we have boundary here, 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 here. This is 8. So again, it could be 4. Okay, can it be 4? If it's 4 digits, that would be 8 with either 125 adding up to 8 or 134 adding up to 8. But they have to be in the same region as these, and we already have a 3 and 5 here. So this cannot be 4. It must be 3 digits here. And we can't have 3 and 5, so we either have 2 and 6 or 1 and 7 as the triplet here. Okay. This is a 1. Can this be, well, 5. This has to be the middle run. It cannot be the last, it cannot be the, can't be the, I guess it could be the first part. So it's either the first or the second run. It cannot be the third run, right? Because we could have singleton, blank. You have a 2-digit sum, but then you have to have a blank between that and any other run. So I guess the answer is no. Okay, so this is adding up to a singleton digit, which is at most 3 digits, right? Because 4 digits adds up to, at minimum, 1, 2, 3, 4, which adds up to 10. So these 2 digits are guaranteed not to be filled. Oh, we have something here too, which is similar in column 3 as the same as column 15 or column 5. So this also has to be green, blank, green, blank. This is part of the same region. 2-digit number, blank, singleton, blank, singleton. Okay. Okay. So because we have that, we know these are part of the same. This is a 4, which means 4 cannot be here. Where is the 4 in that has to be a singleton here for this Japanese sum? It has to be here. So that's 4. These are all the same region. So, and this 4 cannot be the same region as that. So this is a separate boundary. That means this must connect this way to form a orthogonally connected region. This is 4. This is a 2-digit sum, so this could be anything from 2 through 7. Cannot be 4 because of 4 in the column. These 3 digits must add up to a 10, essentially. So this is not part of that region, and this is a 3-sum region, and this is empty, so this must be a 2-cell region here, adding up to 10. So it cannot be 2, 8, it could be 3, 7, or 4, 6 here for a 2-digit sum. Okay. These are all, so this is 1, 7, or 2, 6. Aha! To add up to 8 plus 8, which adds up to 16. So we are guaranteed there is no 6 or 7 in the rest of row 6, because this is either 1, 7, or 2, 6. This is 3, 7, or 4, 6, adding up to 10. That means there's guaranteed 6 or 7 here, 1 out of 6 or 7, and guaranteed 1 out of 6 or 7 there, which eliminates 6 or 7 in the rest of the row. So this must be 1 through 5 here. Hmm. Okay. Can it continue here? It could. So this could be all of these digits here, 1, 2, and 3. We know this is guaranteed to 1, 2, and 3 because it's part of this region here. Because every run is part of the same region. This is part of the same region. We have a 5 here. We have to have something adding up to 8. So can 8 be here? So we have 8 here, blank, but this is a 2-digit sum here. So this cannot be 8 here, which means this must be the 8 here. Is this 8? We have boundary here, boundary here. We have a 2-digit sum, and then you could have a singleton. Or you could have 3-digit sum with a singleton, or 2-digit sum here with a singleton. So 2-digit sum, singleton, 3-digit sum, 3 digits summed up, and then a singleton, or 2-digit here and summed up. So this is guaranteed to be a finished digit. Okay. This run could be fine. We could have that be part of a different region. This cannot be 4, 8, 1, 5, 3. So this has to be 2, 6, or 7. This can't be 4 either, so it's 2, 6, or 7 there. Okay. There's no way that this can be part of this region here. So to make a fully valid region, we have to go all the way here. Because we need 8 cells in the orthogonally connected region. So this is valid as a region and is done. So this is a 2, which makes this not 2, that's 1 or 3. This must be part of a region here and is 1 or 3. And these cannot be part of this region, but it could technically be part of this region here because there's no restriction on that for Japanese sums. This has to go out, so that's only 5 cells at most. So this has to go out this way for the 6th. This can't be 2 because of 2 in the column. This adds up to 19. So these are all part of the same region. This adds up to 19. This adds up to a 2-digit sum. And this adds up to a singleton that we have. And we have to have a 2-digit sum here. Well, can this be part of this region here? I think the answer is no, right? 19 plus a 2-digit sum plus another 2-digit sum. Yep, it's already 39 at minimum. So this has to be a separate region than this. And this has to get out somewhere, otherwise it's not going to be able to form a fully connected region. And so we have to have 2 digits. So it can't be just 2 digits here, because if it's just 2 digits here, it's not going to ever be able to connect out. So this has to be, we have a 2-digit sum here. How does that work? I don't like that. That's not good. Huh. That's a problem. Because this has to be 3 at least. Then you could have space. Then you have to have 2 digits. Oh, it doesn't have to be blank. Okay. That's the reason why. Okay. Yeah. So that's okay. Yeah. This doesn't have to be blank. That was a bad. Well, that was really bad. Right. So we are guaranteed, yeah. This has to be part of the 19 run. We have to have a 2-digit at least run here, which adds up to a 2-digit number. So it's going to be at least 2. It could be 3. But it can't be more than 3 because then this run would not have a blank. It would not be flanked by a blank empty cell. So this is guaranteed to be a digit, which means this must be a 2-digit run here. Okay. That makes more sense. Right. Column 3 is still the same, so that's fine. This cannot be part of this run. We don't have any information there, so it must be either going that way or that way. Okay, so yeah, this was incorrect assumption because there's a star there. I totally forgot about the star. That was my bad. I messed up there. One cannot be part of the 5 then. One has to be part of the middle run. It can't be this part of the star run because you can have 5 blank 2-digit sum here, and then you have to have a blank there if that were the case. So 1 is part of, it can't be part of the 5 because this is part of the 5. If we try to connect them, we have 1, 2, and 3 at minimum as a set, which would add up to 6. So this 1 has to be part of the middle run, which means we have 2 other digits at least in this run. Not sure where. Okay. Four cannot be here because of 4 in the column. Remaining digits in column 3 have to be 1, 2, 3, 5, 6, 7. Obviously no 3 here because of 3 in the column, or row, and 1 here because of 1 in the row. This could be a singleton 5. That is possible. Oh, this is a blank here. Because that's a 2-digit run. This has to be a 2-digit run somewhere here to add up to 11, and it has to be 5 and 6. So this can't be 6 here. And it's either 2 digits here, 2 digits here, or 2 digits there, but we don't know any of them. 7 has to go out here to orthogonally connect. This is boundary here. Maybe we should make this light gray. Dark is kind of hard to see the boundaries. Yeah, or medium gray. Does light work? This light's too hard to see. Medium's nice mix so that we can see the boundaries here. What else do we have? This digit must be 1 through 4. Ah, and this 2-digit sum must add up to a 2-digit sum. So we cannot have 1 here. This, then, cannot be 5. 5 and 4 adds up to at most 9, which is a 1-digit sum. Can't be 6, so this must be 7 or 8 here. Okay. What else do we have? Okay, so this is part of this set. And it cannot be the star set because we can't have one blank, one cell blank, one cell blank as possibility. So this must be at least the middle one or the upper run. So this has to be 1 or 2 to add up to a singleton run. We have to have a blank there because otherwise, if it's not blank, it would be part of the run, and we'd have 1, 2, and 7 at least, which adds up to 10 at minimum. So this is done there. You could have 2 and 1, or 2, 1, or 3 and 1. This has to be 1, 2, or 4, obviously. One of these is guaranteed 5. Boundary here. This has to be, okay, can this be 3 by itself? Then you have 2-digit run and then 8 blank, then 8 off the edge, which doesn't work. So this has to be a 2-digit sum here. This has to be the third run. We don't know how this is ordered here. This is the second run. We could have other runs here. Oh, this is guaranteed to be a run. And it has to be a singleton. So this is blank, this is blank. And this must be a 2. So this is 2. That's not going to add up to a 2-digit sum. 7 and 2 at most adds up to 9. So this must continue on here, which means it has to end here because we have to have another run of 8 here. So this is boundary. And this must be an 8. This is 2. This cannot go down then. If it goes down, it would have to be, as a singleton, it would be a 3. And if we had a doubleton, it would be 1 and 2. So this is done as a boundary. We cannot have 3 be there. We can't have, it has to be 3 by itself. 3 cannot be there by itself, so that's blank. 3 could be there by itself, so that's fine. This has to go out this way to be able to form a valid region. These are separate regions then. 1, 2, 3, 4, 5, 6. We have to go 7. You cannot be part of that region because then that would be a 9-cell region. So it has to be 7, 8 here. And then this is done as a region. Okay, 4 can't be here. This is 1, 2, 6, or 7, and this could be 4. One of these is guaranteed to be 4, I should say. This goes 1, 2, 3, 4, 5. This has to go up then. So this is part of that region. So 1, 2, 3, 4, 5, 6, 7. And we could have an 8th there or an 8th here. We're not sure. Or an 8th here, technically. No. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it's too large. So you could have an 8th here or an 8th here. We're not sure which. We do know that this is boundary, though. Okay, this is a 2-digit sum. This is a different region, so this must go that way. It can only be 3 or 1 and 2, but it can't be 1 and 2 because of 1 and 2 in the column. So this has to be 3, which means this can't be 3, no 7 here. This cannot go up. We have to have a boundary there. So then we have to go this way to continue on as an orthogonal connected region. This could actually be part of this region here. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, you can't. We don't know if these are part of the... This is definitely not part of this region because this is part of a region. So this is all part of the same region here. That means this has to go up. 1, 2, 3, 4, 5, 6 at least, maybe 7, maybe 8. 1, 2, 3, 4, 5, 6, could be 7, 8. That is possible. Okay, not really certain about how this breaks, how this works. We got a boundary here. And in fact, so this is done as a region. This can only go one more. So what region is this going to be part of? It has to be part of this region as an 8-cell region. So then this has to be 5 and 6 connecting to here. 1, 2, 3, 4, 5, 6, 7, 8. So then this is the region there, which means there's no, this is region. That's done. These are blank because of the Japanese sum, and this has to be 5 and 6 as a pair. This is a single digit. Remaining digits are 1, 2, 4, and 8. And this can't be 8 because of 8 in the row. This can't be 4 because of 4 in the row. We have a guaranteed 4 here. One of these two is 4. So that means this cannot be 4 here. It's 1 or 2. 2 eliminates... This has to be part of a region. It's now part of this one, so this can't be 2. It's 1. That eliminates 1 in the rest of the column. So this can't... This is 2, 4, 8 as a triplet, which eliminates 2, 4, 8 in the rest of the region. So this can't be 2. It's 1. There's no 1 here. We have 5 or 6 here. This 2 or 4 here. This could still be 3. This cannot be part of a region because of the Japanese sum. So this could be part of this region, but we don't know. This is border here. So we have 1, 2, 3, 4 regions. This is 5. 1, 2, 3, 4, 5. This is the 6th region. We have 2 more regions here. Okay. These digits can be 1, 2, 3, 5, 6, 7. Obviously, no 5s here because of 5 in the row. No 3s here because of 3 in the column. Hmm. Adding up to 19 without an 8 and with a 6. So 19 minus 6 is 13. But we don't have 6, 7 available, and we don't have 5, 8 available. So this has to be 4 cells at least. Obviously, it's not part of this region, so it's either this 4 or this 4. Either way, this is guaranteed to be a valid cell. And we have, 1, 2, 3, that's 7. Okay. No 1, 3, or 6 there. So that's 2, 5, 7, 8 are possible. 8 cannot be here because it's part of this region, which is part of this region, which is part of that region. We have a guaranteed 5 in one of these 2 cells. So that eliminates 5 in the rest of the region. Interesting. This is 2 or 7 here. We know in one of these cells is a 4, and the other has to be a 2 or 7. Well, that's not true. That's not true. Never mind. Okay. Oh, well, this is 4, which means this can't be 4 here, which means in this region here, this has to be a 4 because of the 2-8 pair in the column. 4 eliminates 4 here, so this can't be 6 to add up to 10. This is 2. This cannot be, this could be 1. So it could be 1, no 2, 3, 4, 5, 6, or 7 there. Okay. This adds up to 19. So we don't have 4 available. We don't have 8 available. It's at least 4 digits. Can it be 5 digits adding up to 19? That would mean 4 digits. What is it? 1, 2, 3, 5, 6? Is that possible? 1, 2, 3, 6, 7 works. So it could be 5 digits. Or it's 4 digits. We don't really know. We have to have a singleton and then a double. Double digit sum. And this can't be double digit sum by itself. So that's not possible. So this has to be 2 here, either here or here. That means if it's 2 here, that's still blank. If it's 2 here, that's blank. If it's 3 here, that's still blank. So this is guaranteed to be part of a, this has to be some cell. We don't know which. Okay. This has to orthogonally connect out, so therefore it's there. Ah. 1, 2, 3, 4, 5, 6, 7. It has to go down. And it has to be a 3 there. So since that has to go down because it doesn't have anywhere else to go, because that's 7 at most here, it has to be 3 going down this way or that way. And therefore the rest of the row cannot have anything in it. So one of these is a 3, and it's part of this region. So this cannot be 2, 3, 5. It must be 1, 4, 5 here. So this is 5, this is 4, that's 1. That eliminates 1 and 7 in the rest of the row. So this is a 2, 6 pair, which eliminates 2, 6 in the rest of the row. So this can't be 6, it's 3 and 7. That eliminates 7 there. 1 is part of this region. 1 can't be here then. 2 and 6 eliminates 2 and 6 in the rest of the row in the region. So this can't be 4, 7. This has to be a 4, 7 pair, which eliminates 4, 7 in the rest of the region. This can't be 7, it's 1. So there's no 1 here, no 1 here, no 1 here. 4, 7 eliminates 4 and 7 in the rest of the row. So this can't be 7, it's 2. And this has to be 1, 2, 3, 6, 7 here then. So 3 has to go down here. Yeah, because it doesn't, otherwise it doesn't add up to 19. Right? These already add up to 17. 36 minus 17 is 19, so the rest must be here. And it cannot connect to there because then that would be no blank. It would not be flanked by 2 blanks. So this has to go that way. And this is done as a region. This has to be 3, and that's 7. That eliminates 7 in the rest of the row, so no 7 here. That's 6, no 6 or 7 here. That's 8, no 8 here. That's 2, which makes that 8. This can't be 8 or 7 because of the 4, 7 pair and the 8 in the row, so this is 6. 8 eliminates 8 here, so it's 7. 7 eliminates 7 here, so this is 8. This 4 eliminates 4 in the rest of the column. No 5 here, no 5 here because of 5 in the column. 1. This can't be 2. There's no more 6 in this region. There's no more 2 in this row. 7 eliminates 7 here. So it's 5. This can't be 5 or 7. It's 3. That eliminates 3 in the rest of the region here. This must add up to a double-digit sum, but 2 and 7 do not already. So this must be adding up there to add up to a two-digit sum. So that's done as a region. This is blank here. And this must be 1, 2, and 7. And this can't be 1 or 7 because of 1 or 7 in the column. So that's 2, which makes this 7, which makes that 1. 7 eliminates 7 here, so it's 4 and 7. 3 eliminates 3 here, so it's 1 and 3. That eliminates 3 in the rest of the column. So we have a singleton 2. Okay, so what is done? This is a two-digit sum. This adds up to 11. We have 5, 8, 10, 4. That's fine. Nothing here, nothing here. 6, 8, 8, 7, 1. That's fine. 10, 16, 10. That's fine. 3 and 2. This is not a digit. This is blank because of this must be surrounded by blanks. So this is green and green. So this is not yet done. This cannot connect to these two, and we have to have a blank here. So this must be blank. That means this is part of the two-digit sum here, so that connects this way. So we have boundary here. This must orthogonally connect out, so this is there. This must orthogonally connect out to form an 8-cell region. So we have 1, 2, 3, 4, 5, 6, 7. So could either well, actually, we don't even know. 1, 2, 3, 4, 5, 6 guaranteed. It could go 7, but then it would have to go 8, 9, 10. So this cannot be part of this region here. Because if it were, it would be too large of a region. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is too large. So it cannot go to here, but it could go 1, 2, 3, 4, 5, 6, 7, 8. So this is definitely part of this region. So this cannot be 3 because of 3 in the region. This is 2. This has to be 5. This digit cannot be 2, 4, 6, 8, 5, or 7, or 3. So this is 1. That eliminates 1 there. This can't be 2 because it's part of this region. This has to be 4, 6, or 7 here. 3 is always part of this region. This is a 2-digit sum. This has to go out orthogonally, so it must go to there. These could all be part of that region. We're going to make this red so we can figure out what these are. This has to be yellow. We'll make this, I guess, orange. And we have all these regions set. So this one we don't know. It could be red. This is obviously red or yellow. Two-digit sum, but we don't have any other information. What digits can these be? No 1, 3, 8, so we have 2, 4, 5, 6, 7. No 2 here because of 2 in the row. No 5 here because of 5 in the row. Huh, interesting. This is a 2-digit sum. This cannot be part of yellow. We have 4 yellows. This is a 2-digit sum. It has to orthogonally connect. This has to orthogonally connect to something. So it has to orthogonally connect to that 2-digit sum. And then this is too big because that's 9 cells. So this is not part of yellow. It's not part of red. It has to be part of green, of orange. 4, 5, 6, 7, 8, 9, 10. No, it can't be. Wait, what? No. That's a problem. Huh. How many regions do we have? 1, 2, 3, 4, 5. Yeah, 6, 7, 8. This is not part of any region now. That's really bad. What did we mess up here? Hmm. Oh, it doesn't have to be. This could be all part of that region. Right. Because this is a two-digit sum. So then this has to be part of the orange region. And it cannot be part of this region. So this cannot go up. So this is all part of the yellow region there. So that's 7. It could be 8 there. It could be 8 there. We don't know. Can't be 8 there. There's too many digits already in row 10. So this is empty. So then we have to go yellow there. That means red has to go there. We don't have any information here. This is orange because it can't be red. Red is done as a region. Yellow's done as a region. And this has to be 5 because that's the only digit missing in yellow. Orange has to connect orthogonally to the rest of orange. Okay. This digit has to be 4, 6, or 7. Cannot be 7 because of 7 in the column. These digits are, we have to have, okay. So orange digit, okay, so this has to have 2 digits as orange, so it must be orange, orange there to orthogonally connect. And that's done as a region 2. So then the rest are not filled. Okay. Remaining digits of orange. We have 4, 5, 6, and 8. No 4 here because of 4 in the column. No 8s here because of 8 in the row. This 5 eliminates 5 here. That makes that 6, which means this can't be 5 or 6. It's 4. This can't be 4 or 6. It's 5, which makes that 8. 6 eliminates 6 here, so that's 2 and 6 there. 6 eliminates 6 here, so it's 4, which eliminates 4 in the rest of the row. We have remaining digits in the yellow region. Okay, let's just double check these. Okay, 5 eliminates 5 here, so this is 6, which makes that 5. Okay, this is a 2-digit sum. 11, that works. 5 blank 8 blank 10 blank 4, that satisfies that Japanese sum. 6 blank 8 blank 8 blank 7 blank 1, that satisfies that. 10 blank 16 blank 10. 3 blank 2, nothing here. 10 blank 5 blank 10, which is a 2-digit sum. 5 and 7 digits, which is 31. That satisfies that. 4, 19, blank 19. 1, 2, 7, and 6, 3 is 19 plus 13. Blank 13, that works. 26, blank 4, and then we have star, so that's fine. 3 blank 4 blank 13 blank some digit blank some digit. 2 blank 6 blank 13 blank 3 blank 1. 2 blank 8 blank and then star. 6 blank 3 blank 725 is 14 blank 8. And those are all the Japanese sums. So this should just be filled out by normal Sudoku. This digit cannot be 1, 3, 4, 5, 6, 7, or 8. So this has to be 2. That eliminates 2 in the rest of the row. 4 cannot be either of these. So where's 4? 4 has to be here. 7 cannot be either of these because of 7 in the column. So I was using 4 in the column previously. Now I use 7 in the column, so 7 can't be here. So this must be 7. That leaves this as a 3, 6 pair. This can't be 6 because of 6 in the column, so that's 3, that's 6. 7 eliminates 7 here, so that's 6 and 7. And that's the solution. Very cool, actually. It was very interesting how these interacted. I made a kind of mistake here earlier, but fortunately I was able to figure that out without backtracking too much, which was good. Interesting logic behind this for especially for the Japanese sums, right? And then combine that. This is sort of more like chaos construction instead of chaos deconstruction. But it was pretty cool. Anyways, I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.